previously unknown branch of life dominated Earth 400 million years ago. And yeah, that sounds kind of crazy, so I want to learn about that. By Anton Petrov.
Hello, wonderful person, this is Anton, and today we're going to be discussing a kind of a follow-up to a very strange biological mystery, approximately 165 years in the making. Something that puzzled biologists for a very long time, and something that involves this somewhat strange organism you see in this image. An organism that actually dominated planet Earth for quite a long time, and way before the dinosaurs. But also an organism that was one of the largest in existence during this time. Much bigger, and actually dramatically larger, than any other organism around it. And well, this is referred to as a proto-taxa.
Just looks like a stone pillar, yeah. Hello Yamato. Yeah, when continuing with this channel, not giving up. Huh? Thanks for coming over.
For decades, biologists believed they kind of figured out, but based on some of the recent groundbreaking discoveries, turns out they didn't. And turns out that these recent discoveries are actually even more mind-blowing. Because in this case, we might have discovered an entirely new lost kingdom of life. A type of an organism that basically did not make it and did not survive. Even though a lot of other stuff, including of course plants, fungi, and animals, did survive. Which makes this a pretty exciting discovery. Now just as a side note, we've actually discussed the previous version of this study approximately a year ago, and so what we're discussing today is actually kind of a follow-up / update. But because the study by Corentin Loron and the team you see right here has now been peer-reviewed and officially published, it obviously makes it so much more interesting because this is a groundbreaking discovery. But to understand why this is so important, but also why this is so strange, we have to look back at the period when all of this existed and basically try to imagine Earth as it was approximately 400 million years ago. This was the early Devonian period, technically referred to as the Age of Fishes. You can learn a little bit more about this in one of the videos in the description. But in essence, most of the life at this point was actually underwater. But during this era, some of the first terrestrial ecosystems started to be formed as well, but mostly involved extremely simple arthropods, or basically a lot of very primitive animals, including something resembling an insect, and very simple plants. So basically the surface of the planet looked very primitive. And most importantly, on land, there were no forests, with the largest plant, known as Cooksonia, only being something like 10 centimeters or a few inches tall. This was basically ankle-high moss. But rising out of this miniature landscape were these very massive pillar-like structures that could be up to 8 meters or 26 feet in height and towered over everything in the vicinity.
I mean, in a way, people say it all the time, right? You don't need to go outside of the planet to see stuff that feels alien. And yeah, this does feel alien. And even today, there's a lot of like creatures and stuff that feel alien. Yeah. This is something out of like No Man's Sky.
These were prototaxites, strange organisms that contained no branches, no leaves, no flowers, and were basically the giants of this era. And for over a century now, the question was basically, okay, so what exactly is this? With the first question being asked back in 1843. And this is when the first fossils were discovered, and by 1859, they started to be known as prototaxites, which basically just means first yew. Kind of like the yew tree. And obviously because some of the earlier archaeologists actually thought these were tree trunks. Giant partially rotten conifer trees from the age of the dinosaurs. But by 1872, a researcher named William Carruthers started to argue that these were actually very strange organisms, most likely made out of marine algae, or basically a kind of a chunk of seaweed that somehow ended up on land. And that's because the structure here did not resemble a tree, and contained a lot of features that we don't expect from a typical plant. And here's actually roughly how this was imagined at first, with this image from 1888. This debate between the rotten tree trunk or some kind of a giant seaweed lasted for quite some time. Mostly because the fossils here did not have any of the clear features we expect from something like a plant. But in early 2000s, and specifically 2001, this debate sort of switched to a different proposition. These were now believed to be giant mushrooms. Because when looking at this structure under microscope, it seemed to be made out of millions of tiny interwoven tubes, which resembled a typical hypha we find in modern mushrooms. And so for a typical fungus, we usually find something like this, or something like this. This is actually one of the most famous hypha from penicillin, the most important and the most famous fungus in existence. And while some of the prototaxites also seem to contain very similar features, but they were not exactly the same. But still, the fungus explanation made more sense, especially based on a lot of other studies, including this very recent one, that provides a lot of evidence that a lot of fungi occupied a lot of land environments hundreds of millions of years earlier than previously thought. As a matter of fact, fungi very likely predated plants and were possibly the first to colonize land. We'll actually discuss the study in a separate video because this is also kind of groundbreaking, but in essence here the fungus idea made a lot of sense, and especially because in 2007, additional studies using carbon isotopes revealed that prototaxites were not actually making their own food from sunlight like a typical plant. Instead, they seem to be heterotrophic, meaning that they absorbed organic matter in the soil very similar to a fungus. And so here we had direct confirmation that whatever this was, it was definitely not a plant and seemed to be somewhat similar to a fungus, except that this was a 20-foot tall fungus, much larger than anything that we have today. But as things usually happen in science, once we get new technology, certain older discoveries can be actually overturned. And that's actually what happened in 2025. This recent study...
It seems to happen a lot. I mean, in a lot of the video you guys have showed me of prehistoric or hundreds of million years ago science, they talk about that, right? A lot of stuff, you know, in just a decade is often overturned, yeah, often changed. Which is interesting, you know, like, so many times people will be convinced this is the answer, only to, you know, for that to completely be changed on its head later on, yeah. When will you visit Japan? One day, when I have money, one day, yeah. I don't think anytime soon, if I'm to be honest. I wish, but yeah, there's no way, right?
Now published in the Science Advances, completely challenged the fungus theory by focusing on an exceptionally well-preserved specimen of prototaxites discovered earlier in Scotland. And so here, by using the advanced technology involving 3D laser imaging and infrared spectroscopy, researchers were able to look much deeper inside the organism and analyze its molecular fingerprint better than ever before. And well, what they've discovered is a little bit surprising. First, let's discuss the anatomy. While fungi usually have a relatively simple network of tubes, as seen in some of these images, turns out that prototaxites possessed an extremely complex internal structure, with researchers discovering at least 3 different types of tubes that connected in dense hubs, now referred to as medullary spots. And that's not something that fungi contain. And here, by using 3D reconstruction, they saw that these tubes branched wildly and seemed to be interconnected in a way that modern fungi
looks kind of like coral, you know, underways are coral.
With some of these tubes even containing very strange internal rings, which researchers now believe might have been used for transportation of water and possibly gas. Once again, this is not something that fungi have, but surprisingly, this is what a lot of vascular plants have. Basically, this is something you expect from a tree. But the most important evidence came from the chemistry. Here, by comparing the chemical signature with many other fossils, including actual fossil of fungi from the same time, researchers realized that if this was a fungus, it should contain chitin, a very durable molecule that is actually used by a lot of insects, but that also makes up cell walls of all fungi. It's basically what gives fungi their structure and what prevents them from falling apart. And actually, even after 400 million years, we can still detect traces of chitin in most of the fossil fungi discovered in many different locations. And this is actually what's even seen in the fungus fossil discovered in the same rock that was literally growing next to this prototaxite. But the prototaxite sample from Scotland did not have any chitin and instead contained something very similar to lignin, which is actually better well known as the woody part of a typical plant. Although in this case it was not exactly the same structure and was slightly different in terms of chemical composition. And that was of course a somewhat surprising discovery. Here we had an organism that we thought was a mushroom, but seemed to contain certain features from plants and certain features that nothing else seems to have. Basically, this prototaxite lacked essential building blocks of fungi and did not match enough plants or animals, which led to the new conclusion that this was possibly an entirely different kingdom of life, and something that eventually went extinct. It was not a plant, it was not an animal, it was not a fungus.
I mean, extinct, but at the same time, as you said, it shared some similarities to to eventually fungi, eventually like trees and other plant life. So it went extinct, but a lot of the traits, I mean, I guess no, they didn't pass on because it went extinct, but you know, like life on Earth found a way to replicate those traits into, you know, a kingdom of life that actually survived, sustained, and evolved, I guess. Yeah. Yeah. It's like this branch of evolution of this, whatever you call it, you know, had the same idea, I guess, but not good enough to actually survive in a long time, yeah, or whatever.
It was something entirely different, a kind of a failed experiment. He was possibly dominant on Earth for a very long time, but eventually left no living descendants for one reason or another. And so right now this is a pretty exciting discovery because it essentially challenges our timeline of how we think life colonized the planet. Mostly because for a very long time it was always believed that plants were most likely the first, and were also most likely the dominant forms of life on the surface. But it turns out that before the trees even existed, we already had these very mysterious giants towering over all of the plants, and they were potentially extremely important because their fossils are quite prominent and seem to exist everywhere on the planet. As a matter of fact, based on their structure and potential function, we can actually assume that these were very important ecosystem engineers, or basically that they help distribute nutrients across various landscapes, and due to their sheer size also provided homes for some of the first land-dwelling insects and arthropods. As a matter of fact, researchers reported a lot of different boreholes in many different prototaxite fossils, and that of course suggests that these ancient bugs were living inside of them, and possibly were even eating them for millions of years, way before trees even existed. But during the late Devonian, all of this went extinct. Nobody knows why, but today the assumption is that they were probably outcompeted by actual real trees. Trees that were very efficient at capturing sunlight and had to grow tall and basically cover everything in order to be successful. And so once the forests became prominent, prototaxites disappeared. And well, right now this is a pretty interesting evidence for all of this, for basically this fourth branch of life, but we do need additional studies and additional research to see if this actually makes sense. Right now this is just one team and one proposition, and though the giant mushroom theory is still the more widely explained explanation, based on the data and the analysis using molecular fingerprints and 3D imaging from this study, we now have a much more interesting and more complex tale involving something we didn't even know existed. A strange lost kingdom that once towered over everything else on Earth, only to one day disappear and leave us guessing about what exactly this was for 2 centuries. But we still have so much to learn about all of this, and there's still so much to discover about early Earth and how life on Earth colonized the surface. And it's this exciting mushroom study we're going to be discussing next, because the discovery from that study might even rewrite modern textbooks and our understanding of complex life on the surface. So we'll definitely come back and discuss all of this in some of the future videos. Until
That was, yeah, this seems to be it for that part. Huh? As I always said, like I wonder, like in 50 years, you know, with how fast technology has advanced over the last 50 years, so like, yeah, in another 50 years, yeah, like how much of what we think is right today will have been proven wrong by advancing technology, research, and discoveries. Yeah, I mean, yeah, a good thing would be like if I'm still around in 50 years, I'll do a YouTube video trying to find some textbook from like 2010 and comparing it to textbook of 2050 to see how much has changed. I guess I'll do that in 50 years, you know, when I'm like a 77-year-old YouTuber. I'll be doing that. Remind me in 50 years, guys, if you're still around, remind me to do that video on YouTube at 10. I'll do that. Very interesting. I always find it fascinating, this kind of stuff. Even if, you know, some of the information right now might be wrong, you know, just the idea of it is really interesting. Yeah. Okay. Well, good stuff.